Hello, my name is Ivy Hines and welcome to my Teach One presentation. This presentation was prepared as part of the HAP 823 Comparative Effectiveness taught by Ronald Woodaman, PhD, at George Mason University, Department of Health Administration and Policy. My topic is on stratified covariate balancing, question number 5. Question 5 reads, in a nursing home, data was collected on resident survival and disabilities. The data are listed in the following order: ID, age, gender, number of assessments completed on the person, etc. A. Does an inability to eat increase probability of mortality in 6 months? Use SQL and stratified covariate balancing to determine if inability to eat contributes to mortality after controlling for other disabilities of the patient. B. Does inability to toilet contribute to survival? To answer this question, several steps must be taken. First, later events must be ignored. These are events that occur after the patient is unable to toilet. Second, the stratification need only occur among parents in Markov blanket of unable to toilet. A quick way to identify the parents in the Markov blanket of unable to toilet is to regress it on all the variables that precede it. Then, the variables that are significant and have large effect size must be stratified. Here is a sample of the raw data. I uploaded the data into SQL Server. We first want to clean our data by adding proper labels and getting rid of records where assessments take place after death. When you first upload the data, the columns are not properly labeled, so this query includes the labels and places the data into a temp table called Data. This query puts all records where dead equals 1 into a temp table called tdead. This query selects data where the sum of the column dead is 0, so only records where residents are alive will go into this temp table called talive. In this part of the query, we gather data with two different criteria and use a union to combine the two tables. Here's the first part, and here's the second part, and placing all the data into the temp table data 2. This criteria gets the maximum days first assessment from the data table and only grabs data that is less than or equal to days first assessment from the data table. This ensures that assessments that happen after death are not kept. For a visual, I found a record where there is an assessment after death. There is a third assessment that should not be included. After running the query again, with the assessment criteria, the extra assessment is no longer displayed. The query after the word union are all the records where the residents are alive. Here we want to get all records where residents are unable to eat, and the code uEat equals to 1 will do that. In this query, we need to do a little more cleaning up and remove assessments after eating disability occurred. So, if there are assessments after unable to eat has occurred, they need to be removed. This part of the query takes care of that. In this part of the query, we capture all the data where residents do not have an eating disability and place them into the uEat0 temp table. This is a similar concept in joining the tables through a union instead of joining tables. We are combining resident records where resident is unable to eat and residents who do not have an eating disability. The next two queries select assessments where patient has died and then determine which residents have died within 6 months. In the previous queries, the focus was on death in 6 months. Now we want to determine if the inability to eat increases the probability of mortality in 6 months. Here, we want to get all the data where residents are unable to eat. Here, we calculate the minimum age in the data and put that calculation in a temp table. Here, we want to get the average of the minimum ages and store it into a variable. To do so, we declare the variable @AverageAge and we want the data type to be a float. We then set the variable to the average of the minimum ages. Use this print syntax to see what number was stored in that variable. Here is where we create the strata. After converting all the binary numbers to letters, we then concatenate the letters to create the strata. This is a snapshot of what the data looks like. The left join is the reason for the null values. Now we can perform stratified covariate balancing to determine if inability to eat contributes to mortality. Into the temp table cases, we sum the number of records where residents is unable to eat and dead in 6 months. This sums the record where the resident is unable to eat and are alive. Here, we sum the number of residents that are dead in 6 months. Here, we sum the number of residents not dead in 6 months. In the last query, we match the strata and put it into a temp table called match. Here is a snapshot of some of the results set. Last is calculating our odds ratio. It shows that it is 0.11 times more likely to die if the resident is unable to eat. Part B of question 5 states, does inability to toilet contribute to survival? To answer this question, several steps must be taken. First, later events must be ignored. These are events that occur after the parent is unable to toilet. Second, the stratification need only occur among parents in Markov blanket of unable to toilet. A quick way to identify the parents in the Markov blanket of unable to toilet is to regress it on all the variables that precede it. Then, the variables that are significant and have large effect size must be stratified. Take the previous query we just created for eating disability and replace all the unable to eat with unable to toilet. Like the previous code, remove assessments after unable to toilet has occurred. One difference in the code is the section where we get the average minimum ages. Instead of concatenating the disabilities, we will leave them as is in preparation for importing it into R. Here is a sample of the data. I saved my file as week5_q5b.csv. Now we move to R. We want to identify the parents in the Markov blanket of unable to toilet and regress. After loading the data, displayed are the column names. Using the generalized linear model function in R, I've saved that to the variable called model. Then use the summary to view our model. To determine the parents in the Markov blanket of unable to toilet, variables that are significant and have large effect size are stratified. Coefficients smaller than -0.4 or larger than 0.4 are considered large effects. So we will stratify on average age, male, groom, bathe, walk, dress, and bowel. Per the question, later events must be ignored. These are events that occur after the patient is unable to toilet. We did that in the last query, so that has been taken into consideration. This query now divides the data into the subgroups. Cases and controls using variables that are significant and have large effect sizes. Now we match cases and controls. The two files for cases and controls are joined where this strata is the same. Here is a sample of the matched query. Calculating our odds ratio, it is 0.025 times more likely to die if the resident is unable to toilet. This concludes my presentation. Thank you for listening.